Hello developers, let's start developing. I am Beko and today we're gonna be taking on the 21st day of Advent of Code 2023. So what is happening here? I read through the description and I have I would say something like Admiral Akbari feeling. It seems that the first task that we need to do is actually just to do a flat fill from a given starting position on a matrix. So that's kind of easy, and we already had to do that in a few tasks as the, I don't know, seventh step in the processing. But now it seems that the first part is just to do a flat fill. Okay, let's start with it and we'll see what the second part is, and that could be a special kind of problem. So we have two parameters. We have one kind of secret parameter in the input, and that is the step count. So let's just say we need to do 6 steps. Basically, we have an elf that needs to get his steps, and he wants to know how far he can reach using 6 steps from a given starting position. And we just need to count that. So let's do that. Yeah, we will need get neighbors, and this is kind of something guess that this is a three-dimensional thing, and it's really not. Something like this. I will check this code. I don't like in too much index manipulation and so on. So what does it do? I hate. So this is X index, and it's doing it the wrong way around because we usually want to have Y first and then X. But okay, let's go with that for now. Why do we need a for loop? No, all of it is wrong. Okay, we will need to write a wrong, but we will have a flat fill and we will have a start position, which means that we need to have our favorite interface, which is the point. So what we actually need to do first is to find the starting position because it's somewhere over there and it's marked with an S. So input dot find index of finding the row which has, yeah, let's do it with a stupid for loop. We can do it better, but we can say let start x, yeah, start always like this for index. Row index, so I won't be using x and y to match. That is less than the input. This is a row, input of index. Yep, column. If element is s, start is the index of the column, the index of the row. Yeah, as I said, we have them the other way around. And then we will just need to plot fill the input using those parameters. So we need to, yeah, this is a very simple and very recursive type of call that we might run out of stack space on. But let's see. If input of y and x, and actually I will add an O here because that's how the input maps the places that we visited. If the input is not a dot, return, set the input to be an O, O not a zero, and flat fill in all of different places. We will just need to add this here because we might run off array. So if we have that row, and in that row we have an X that's not a dot, is undefined not a dot? Undefined is definitely not a dot. It will just return. We will need another parameter to flat fill when we have the count of steps. The count of steps left. So let's rename this to steps left. And here we can have, say, if we have 0 steps left, well, we're done. Otherwise, we flat fill this with steps -1. So it will reduce the number of steps each time it takes a step. So after all that song and dance, let's print out what the matrix will look like. It will look like this because something didn't go the right way around. Why are we calling flat fill? So it seems that our flat fill is actually starting and finishing immediately, and I think I know what the issue is, that the starting position is actually not a dot. So what we will do, once we find the starting position, we don't really need it, so we can just say, yes, that thing. So it's not an O, it's a dot. And we're gonna fill it with everything, and we're gonna fill it with dots. And let's start it right now. Yeah, right now we have our recursion running. We might need to change that recursion into something different later, but I think that 64 levels should be quite enough. So let's see if this fits with what the task actually wants. It doesn't. Let's take a look at it. So our starting position is this one. We have some dots here. Oh, oh, this is a different task. Hmm. So the task is where can he get, but by making exactly 6 steps. So you can see this point is not included because in order to get to that point, he would have to do 1, 2, 3, 4, 5 steps, and then the 6 step will go make him go either here or here. But 1, 2, 3, 4, 5. Oh, and we do have a bug because we are decreasing the number of steps. We say if we're on the 0th step, we're not stepping. We actually need to do this here. So, yeah, if we run out of array, then go away. Otherwise, yeah, so we need to make the step and then count the step as made. Otherwise, we're just counting before going, so we're getting to a step less. So we're running 5 steps instead of 6. So we should be able to get to this point and this point as well. Eh? Did we save? No, we didn't. And obviously we don't need this console log anymore because we are indeed uh, running the flood fill. This looks more like it, but then why don't we have these? Is it possible that I have the flood fill wrong somehow? Because this is 1, 2, 3 steps, and this is 4, this is the 5th one, but we're going in this direction. Hmm. Let's actually bring that back, so we might need to debug it a bit. Just a sec. We're not changing the steps left, we're adding another direction with one less step. Some steps less. Yeah, so we're starting from 6, 5, 4, 3, 3, 2, 1, and then we got the zeros, and at the very end, we are checking something else. So this will be 0, 1, 2, 3, 4, 5, 1 more. And this is xy, so we need to take care of the y, 0, 1, 2, 3, 4, 5, 6, 7. When the y is 7, 3, 7, with 2 steps, we should run it with 3, 8 as well. 4, 8 with 0. So we were able to get to 4, 8. We actually got here, since we're doing depth first, we got here with 0 steps left, and it says, well, we cannot go any further. So this might be a bit trickier than we want to do, so we want to have the minimum as well. The distance, so to say. Yeah, so we will might need to do some pathfinding as well. Or we need to change this into a breadth first. passing, because recursive passing is usually depth first passing. So we're taking all the steps that we can take from this place, then all the steps that we can take from that place, and so on and so forth. Or we can say just and an O is allowed as well. So we will run a bit more. We will recount some more steps than we have to actually. And then, as I said, you're not only allowed dots, you're allowed S's as well. We can do this. So this will run a few more times. You might see that the filling will be a bit more. Or a bit less, because it doesn't run at all. Let's see. 5, 5 with 6. Not. If the allowed does. If our item is not in the allowed list, then we should return. Yeah, we did run a few steps more, but we basically ran from all possible steps to all possible things. We might need to optimize something for the big input. And now this kind of looks like what we had. So what after we're done, we have this in the input. And I have an idea that will actually filter out anything, because let's see, this is our starting position. Is it possible to get to this position in 6 steps? No, because it's an odd number of steps away. So this will also be impossible. So if we're running an odd steps of number of steps, yeah, so let's do this for the input. Input dot lat map. And we're not gonna do that. This will just give us the items. So we will map each row and each index into a row.map element and syntax, and we're gonna map our this will transform our matrix into an array. Plots. And just log them out. We can keep this to see what that thing looks like. And in order for this to work, we need to match the parentheses. We should get a list of all of the plots where we can actually step on. Yep, we have all of those. Sounds about right. So row index 2, 7, and 8. 1 and 3 and 5, 6, 7, 0, 1, 2, 3. Yeah, that is okay. And we also have our start index, which is, yeah, we're doing a lot more running around, which is 5, 5. And note that 5, 5 is 5 plus 5 is an even number. So that means in 2 steps we can go to 6, 6 or 4, 4 or 5, 7 or something like that. So the sum of the indexes needs to have the same parity. If the steps left is... So we're first gonna filter out all the points that we can reach, and now I will say filter them for each plot. If the steps left is even, it is, but we need to check it, else something like this. So if the steps left is even, that means that our plot coordinate, the distance, yeah, the distance is this match. This is the algebraic distance, that Manhattan distance also called, that we need to get to that point. It doesn't matter when we get there in 2 steps or 6 steps or 4 steps, because whenever we get to that, we can just go back and forth between its nearest neighbor. But we have that distance, and that means that the distance, if we need to take an even number of steps, the distance also needs to be even. And actually we're gonna need the distance anyway. So, and if this thing is uneven, then we need to say it's uneven. So basically we can just do this. And I'm gonna add a few parentheses and fix this up. So the distance needs to have the same parity as the parity of the steps that we need to take. And those plots can be the final plots, and now we can log them. Which means that we should not get 2 and 7, but we should get 2 and 8. Because 2 and 7 has an odd parity, and the distance has an even parity, which the distance will have an odd parity. So we have 2 and 7, which is 9, 3 and 6, which is 9. I think we got the wrong ones. For 2 and 7, we will have 3 plus 7 and 5, 2, 5. Oh, yeah. The parity of the distance needs to be the same as the parity of the steps left. So 2 and 8, good. 2 and 7, bad. Looks okay. So basically both numbers are either odd or even. Let's see if we can do that. So we just need to return final plots dot length. I totally think this is a very, very inefficient solution. It would have been much better to actually change the flood fill into a breadth first search, which means we only mark the steps that we can reach in one steps, and then starting from them, we're doing the parts that we can reach in two steps, and so on and so forth. But this gave us the correct result. Let's try if this will finish in some semblance of finality when we give it the big input, which is 130 times 131 actually. So let's have it run for a while. Oh, no, 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 no. And this is why I hate hidden inputs, because this is a hidden input as well. We should have a relatively wide recursion right now, but it shouldn't be deeper than 64. So we will have 4 to the 64th calls. That's a lot, because we had 4 to the 6th, which is a different thing. So this might kind of never finish. Because right now we have a fan out factor of 4 that we're not really trimming. Yeah. So now that we know that the algorithm basically works, let's do it the other way around. So we need to go back to 6, and we need to go back to this, and just say we have this flood fill that we're not gonna use recursively, but we're gonna say something like along these lines. So we're gonna define a queue that's gonna have all the points, and we will push X and Y on that, and then we will have this kind of a while loop while the queue length is bigger than 0. I think it will try to just move those things here. We're gonna shift from the queue, and since we're shifting from a queue that we already checked, we know that we don't have that. I will call this start X and start Y. So we can just deconstruct our point directly here. And now we can maybe use just the dots. Actually, I like this solution, but we will just need to remove the O. Yeah, the O is not valid, because if you have an O, just skip it, which means that we are going outwards all the time. Yeah, we're growing the queue too much, because some of these checks can be inverted. We can, instead of checking them when we are running the queue, we can check them before we put them into the queue. So if this position is a wall, is a rock, we just say, don't bother, don't run another queue. And that means that we don't need this, and we just, do that. We change the input in both places, I think. and this gotten here. Why? We're setting, cannot set properties of undefined. If the thing is undefined, why did it get here? We should have broken it away. That's weird. Oh, and we're not handling the steps. Come on, it should have stopped at on-code exceptions. We are not handling the steps. That's the problem. Another part of the queue should also have the steps, and because right now we are just steps left used to be a parameter to the flood fill. Great, I ran the wrong task. Good news is the task is solved and is working, but it's not the one we want. Yeah, so let's see. Y is 11, X is 3. Now it's obvious that this wouldn't work. But when we saw it, so let's say steps is steps left. So it's not a point, it's a distance point. Let's say that the distance point is a point with steps. That is a number. So this is a distance point, which means that now we will have to say that this gets here in steps minus 1. And this is totally wrong because we actually want to take steps here as well and then use these steps here. Okay, this successfully broke. Let's start it once more. We got lucky the previous time because all of the steps that we took kept us inside the matrix. What? This is an AND. So if this is... Oh, and I know why I made the mistake, so I will just say it like this. Yeah, let's be explicit. So we have two different calls that says if we go off the grid, continue, otherwise continue. If it's not there, continue. Let's not try to have too many clever pieces of code. And now it just works and it's a bit faster. So let's change both pieces of input. I'm kind of tempted to put this on the first line of the actual input. And see whether this finishes in some reasonable time frame. It did, and it said it's 307 3,751 points. So aside from self-inflicted wounds, where we just were kind of stubborn in what we wanted to do, this was a totally easy task. But let's see now what else is going on. But maybe it will be better if we take that in part 2. So keep developing and we'll see each other when we're solving this task, which I feel will be much more complicated because he needs to get that many steps done and the map repeats infinitely in any direction. Great.